To study motion inside a galaxy, the problem is that we do not actually see any movement. A normal galaxy looks unchanging from year to year and from century to century. What we can measure is the Doppler shift in the line of sight direction, the radial velocity, relative to the average galaxy as a whole. To convert this into speed in the plane of the disk, the rotation speed, we presume that the disk is actually circular, and that tells us the angle of inclination. You'll be doing this for yourself in a later video sequence. The radial velocity varies across the galaxy because of the varying orbital speed. This is shown in this colourful depiction of 21 centimetre line observations. Material moving towards us relative to the average is coloured blue, and as we look across the galaxy, material moving away from us is coloured red. The change from one side to the other indicates that the galaxy is rotating. Here's another galaxy. Again, the colours show that it's rotating, and here's a third example. All spiral galaxies that have been measured show essentially the same pattern of rotation, the same rotation curve. To examine the motion in the plane of the disk, we have generated some computer models. This is a disk. We see it moving here like a gramophone record. The pink spot is about the distance of the Sun from the centre of our visible galaxy, scaled to fit on the screen. It gives us something to identify. If there are spiral arms in this disk, rotating as a solid body like a gramophone record, the pattern of these arms is maintained. However, a real galaxy does not rotate in this solid body manner. Instead, it's rotating differentially. We look at it first without the spiral structure. Material further out from the centre takes longer to go round. Now look at a structure within the differentially rotating material. The outer parts trail behind more and more. In a short time it winds up completely and the structure disappears. This presents a severe problem. Real galaxies have spiral arms that are not wound up. So the answer must be that the spiral structure is a permanent pattern that does not share in the differential rotation. The pattern goes round at a much slower, uniform rate. The material rotates differentially, passing into the pattern and out again. In the density wave theory, the pattern is a concentration of the material. When it enters a spiral arm, it slows up and takes longer to get through. Inside the spiral arm, the density is greater. This is a simple model to show the essential motion. In the theory, the gravitational field produced by the pattern keeps the pattern going, and so it goes on.